Now we are going to learn the condition for constructive interference. First we will see what should be the condition for the central bridgeband. Look at that. The wave from S1 and S2, they are traveling like this: 1 lambda, 2 lambda, 3 lambda, 4 lambda. As a sample wave I have drawn. Both are having same wavelength, 4 lambda, 4 lambda. Finally they are superposing with one another and the central bridgeband is created. Therefore the phase difference between these two is 0. Path difference and phase difference is 0. Therefore central bridgeband is created. There is no delta here. There is no path difference here. What is the expression for path difference? Delta is equal to yd divided by d, which is equal to 0. There is no path difference. That's why the central bridgeband is created. Now very closer to the central bridgeband, dark bands are there. We will see it later. Now this is called as first bridgeband. These two are called first bridgeband. Now we will see what should be the condition for observing the first bridebands. So that's why I have drawn these two separately. Are you clear? On either side of the central bridgeband, who is there? This a dark band is there, and first bridgeband is also there. Are you clear? Draw the wave from S1 and S2. Is it clear? S1, it is traveling shorter distance. S2 is traveling longer distance. Here if you draw a perpendicular line, there you will be getting the path difference. So here 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda is there. Here also 1, 2, 3, 4, 5 lambdas are there. In this portion, equal number of waves are there. Look at the extra wave traveled in this portion. In this portion, in this particular region, path difference extra of 1 lambda is seen. So the path difference between the first wave and second wave is how much? 1 lambda. By the time, is it clear here, which kind of band will be created? First bridgeband will be created. The same condition, 1 lambda, path difference is equal to 1 lambda, it is applicable to this first bridgeband also on the other side. So how will you write the condition for the first bridgeband? Path difference must be equal to, its expression is how much? Yd divided by small d. This distance path difference must be equal to 1 lambda. Are you clear? Now on the other side, there I have drawn the clear picture. Okay. Here, look at the diagram. So here, this is the central bridgeband. This one is the first bridgeband. This one is also first bridgeband. For central bridgeband and first bridgeband, already we have learned the condition. Now, if you go beyond the first bridgeband, there you can observe the second bridgeband. Okay. Now we are going to see the condition for second bridgeband. Draw the waves from first source and second source, S1 and S2. Here, the S2 source from which the light wave, it has to travel longer distance, and here this one travels shorter distance. Draw the perpendicular line. There you will be getting the path difference. This is the distance called delta. Within delta, 2 lambda must be there. The difference between these two waves must be equal to 2 lambda. Only then you are able to observe the second bridgeband. Okay. So for that we can write the condition like this. Delta, whose expression is how much? Yd divided by d. To get the distance, three things must be known. Are you clear? Who are all that? Y. Y is the distance of any band from the central bridgeband must be known. And then d, distance between the screen and the coherent source must be known. Small d is the distance between S1 and S2. If all the factors are known, only then we are able to get delta. So delta is measured only with the help of these three parameters. Within this delta, if 2 lambda is there, we are able to observe the second bridgeband. Are you clear? So here 0, here 1 lambda, here 2 lambda. So everything to be summarized. Like that we can go for the third bridgeband, fourth bridgeband, it goes on like that. So we can write the common condition for observing the constructive interference, that is to observe the maximum intensity points, bright fringes. So path difference for observing constructive interference is del is equal to, path difference is equal to yd divided by d should be equal to n lambda. Are you clear? Where you can substitute 0. If 0 is substituted, you will get this one. If 1 is substituted, you will get this one. If 2 is substituted, you will get this one. So like that we can substitute the number according to the fringes. Now look at the expression. Here y is cross, to get y, what is y? From the central maxima, to obtain the distance of any maxima first band or second band or third band. Is it clear? To get the distance y, we are able to use this expression only in the case of braid fringes. So cross multiply, basically you will get the expression y is equal to delta, is it clear? Cross multiply this. Okay, n lambda d, this d to be cross multiplied. N lambda d divided by d is the expression to get the distance of any braid band from the central braid band. So these expressions are very much useful for calculating certain values, okay, in problems, okay.